Welcome to the short talk on stereo conversion with disparity-aware warping, compositing, and inpainting. My name is Lukas Mehl, and this is joint work together with Andrés Bruhn, Markus, and Schroers. We introduced the task of stereo conversion, which is, for example, used in most 3D movie productions, where a 2D movie is converted to 3D. Given an input image sequence, the goal is to predict the other view of a stereoscopic video, so an image displaced either towards the right or towards the left. In our case, we consider disparity, that is the horizontal pixel displacement, and use it for warping in order to then predict a novel view. When combining the novel view with the input image, we obtain the final stereo image pair, here shown in anaglyph. While there are a few fully automatic methods available that can be used for this task, none of them can provide high-resolution results of production-level quality, which motivates our approach. We start by giving a short overview of our method, but will describe some concepts in more detail afterwards. First, given the image and the depth map, we introduce a method for mapping the depth to disparity. We then use a feature extractor to obtain multi-scale features on 3 resolution levels and perform warping and foreground-background compositing using the disparity. Finally, we use a self-attention layer and a gridnet architecture to synthesize the final image. We also introduce a strategy to select additional frames from the input sequence and use optical flow-based warping to get multi-frame features. Let us look more detailed at the warping and compositing. With the input image and disparity, a naive warping would result in artifacts. In contrast, our warping correctly composites foreground over background in case of occlusions and leaves these occlusions unfilled, which will be resolved in the next step. We additionally warp the disparity by itself and close warping holes. Further, we compute a map counting the number of splats per pixel as well as a disocclusion mask. Going further to the image synthesis, we can see the input image and the warped image and need to perform inpainting. When using standard inpainting, such as the llama approach, reasonable results are obtained, but foreground objects are wrongly extended. Our image synthesis, however, learns to perform inpainting only based on local background information. For our multi-frame approach, shown in the bottom row, we consider an additional frame that shows key background areas unoccluded, such as the mountains. We warp it using optical flow and only keep information in the disocclusion areas. When using these multi-frame features for prediction, the background reconstruction is improved. We compare our method against other approaches from the literature on 3D movie data. As can be seen, our approach gives significantly sharper results. Quantitative evaluations further prove this, where our method outperforms existing approaches by a large margin. For further technical details, additional ablations and experiments, we refer to our paper and poster. Thank you.